Hi, this is Mrs. Cribb. We're going to go ahead and start chapter 3. So I need you to pull out your notes and also your targets. Every time we do a new chapter, please pull your targets out so you can follow along. I'm going to go back and forth between the notes and the Prezi. So this is the notes to begin with. We're starting our first chapter really that has a lot of math. Sorry about that. So measurement is the act of comparing an unknown quantity to a standard unit. And so I'm going to highlight and underline things that are important. So we have a standard unit, something we all agree on, and we measure something, compare it to that unit. It consists of a number and a unit. So a measurement always has a number and a unit, like 20 centimeters. That has a number and a unit. And a dimension is a measurable quantity. So a dimension is a measurable quantity of a system, like we can measure length or volume or time or the charge, like +2 or -3. It must have a unit associated with it, like meter or liter or gram. And you'll see those a lot in chemistry. Calibrated is when a scale is accurately subdivided, like your thermometer. It's subdivided into measurements. And so we calibrate something to make sure those subdivisions are good. So an example, we have to explain and draw how to calibrate a Celsius thermometer, or degrees Celsius. So what we do is we start off, and I'm going to draw a beaker right here, and it's going to have some water in it. Okay, and I'm going to, in one beaker, maybe this is going to be at 0 degrees Celsius. It's going to be where it just begins to freeze. Okay, so this is going to be ice water. So I'm drawing some ice cubes. It really should all be floating. And so I have a thermometer, or I put something in it. Whoa, that was awful. And wherever the mercury rises, and mercury is kind of a silver looking metal, wherever it rises to, as it's stuck into that cold water, I'm going to mark on that spot. Okay, that's our first fiducial point. And that spot is going to be 0 degrees Celsius. 0 degrees Celsius, that spot. And then I'm going to have another beaker. And this is a big flat beaker, obviously. I'm going to put some water in it. And I'm going to put a Bunsen burner or a flame or heat underneath it. And this water is going to start to boil. Okay, so you see lots of bubbles because it's boiling. And when it reaches the boiling point, that same container with the mercury in it, the mercury is now going to rise even higher because it got hot, and we have something called thermal expansion. It gets hot and it goes up, and wherever it goes up to, I'm going to mark that spot, and that spot is going to be 100 degrees Celsius. So now what I have when I get done is I have that container, that long tube, and I have mercury in it. And I have two spots marked. I have the 0 degrees Celsius spot, and I have the 100 degrees Celsius spot. And I just divide it into 100 markings. And that's how you calibrate a thermometer. You just divide it. Like I could divide it halfway. That would be 50 degrees Celsius. And then 50, 60, 70, 80, 90. So, and then below it would go down to 0. That's how you calibrate the thermometer. So be able to explain that and draw a better picture than I just drew for that purpose. Now let's go on to the metric system. The metric system is based on units of 10, which is really nice for us. And the metric system is called the SI metric system from 1960. You don't have to worry about that. The things you need to know. The quantities we're measuring, length, mass, and time, and temperature. That's the ones we're going to deal with right now. We're not worried about electrical current in this class. We're going to figure out moles in the second semester, so we don't have to worry about that right now. And we're not worried about the intensity of the light. So just length, mass, and time. That is our quantity that we're measuring, our dimension. And the unit for length is meter, and the symbol for length is an M. You need to know all of those things that are associated. Length is measured in meters, and the symbol is an M. Mass is measured in kilograms, and I will also accept gram. And you'll understand when we get to a little bit farther in the notes. And the unit is kg. Time is measured in seconds, and the unit is just an S. Temperature in kelvins, and the unit is a K. These are the SI units. You need to know the SI units. And I marked out the ones you don't have to memorize, but the others you must memorize. From these base units, you can derive, which just means do some math, and you come up with the other units. And I'm not going to worry about deriving them for you right now. Some of them you might come across later on in the year. And then what we're going to do now is when we work with units, it's super important to remember the prefixes. And so the prefixes you're going to have to memorize. I listed them down here at the bottom. Memorize giga. Well, where's giga? Right here. Mega, which is right here. Kilo, hecto, deca. Then this one right here does not have a prefix. This is the one that we'll call unit. And you'll see that when we do our little mnemonic device. Deci, centi, milli, micro, and nano. All the way down. So they're all here. And basically, on this chart, you have to memorize from here to here. All of those prefixes you must understand. So giga means 1 billion, a billion, or 10 to the 9th power. So think about this. A billion has 9 zeros, and that's where that 9 comes from. Okay? It's 10 to the 9. Or you could write it as 1 times 10 to the 9. Mega million, mega million. I always say mega million because I think about the lottery. It has 6 zeros, so it's 10 to the 6th, and it's million. Kilo means 1,000. Hecto means 100. Deca, like a decade, it means 10. Remember, a decade is 10 years. So 10. It's 10 to the 1. Notice how it's going 9, 6, 3, and then 2, 1. And we're going to make up for those differences in a minute. Deci means 10 to the minus 1, or 1/10. I always think about it as 1/10, which is 10 to the minus 1. Centi is 1/100th, or 10 to the minus 2. And think about centi like there's 100 cents in a dollar. So a centi is 100th. It takes 100 pennies to make $1. Milli is a 1,000th, or 10 to the minus 3. Micro is 1/1,000,000th, and then or 10 to the minus 6, and nano is 1/1,000,000th. Okay, now I have this. Now make sure you have all that covered. Make sure you've made these notations in your notes about all these units and everything you need to know about them to memorize them. You have to memorize the prefixes. And I have this little mnemonic device, and we say it to a rhythm just like we do lots of things. It goes gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk, space space micro space space nano. All right, now giga is the biggest one. Giga was what? 10 to the 9th. And then so this was giga space space, and mega is 10 to the 6th. Well, this is 8 and 7. So I see how the space accounts for 10 to the 8th and 10 to the 7th. So gigaspace space, megaspace space, King Henry. King is for kilo. L-O. Did I spell that right? No, only one L. What am I doing? Let's just write that correctly so I don't feel super terrible. K-I-L-O. I understand it better when I write it that way. Kilo for 1,000. There are 1,000 things. Henry is hecto. Right there. D is for deca. And drink. U is for unit. And so that's why I put unit up here. Unit is for unit. There's no prefix in front of that one. And then this second D is for deci. The second C, well, it's the first C, is for centi. And that M is for milli. Okay? So kilo, hecto, deca, unit, deci, centi, milli. Gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk. Space space micro, 10 to the minus 6. space, nano, 10 to the minus 9. Micro is a million, micro millionth, mega million. Micro is for 1 millionth, nano is for 1 billionth. Well, no, notice that milli is right here, is 10 to the minus 3. So this is minus 4, that's minus 5, there's minus 6. That's minus 7, that's minus 8, there's minus 9. So that's why I have those spaces there to kind of make sure you understand how many places to move it. Gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk. Space, micro, space, nano. We will use this to help us to move our decimals. We are going to use unit conversions, but you can use the place movement of the decimals as kind of a check. Okay? Now, you will also need to know these things. 60 minutes is an hour. 60 seconds is a minute. 1,000 meters is a kilometer. 1,000 milliliters is a liter. 1 kilogram is 1,000 grams. You must remember that a gram is about the size of a paper clip, the mass of a paper clip. A kilogram is about the mass of half a pound. So you've got to get these things straight. Memorize these, okay? Now, unit conversion consists of multiplying the measurement by a conversion factor. And a conversion factor is a fraction that contains the original unit and its equivalent value in a new unit. So here's some examples. I just told you up here this relationship. Let's see, milliliters and liters. Right there. There's the relationship. There are 1,000 milliliters in a liter. So I put 1,000 milliliter is a liter. They're the same distance or the same amount. If this container contains, if on this side it said 1,000 milliliters for that, on the other side it could say 1 liter. It's the same amount of liquid. So it's like putting the two things that are identical to each other, one on top of the other, like 2 over 2. That equals to a 1. So these are the same things on top of each other, so they equal 1. So the first conversion factor, I could put 1,000 mils on the top and 1 liter on the bottom. Or I could put 1 liter on the top and 1,000 mils on the bottom. It depends on what I need to do, which way I need to convert. Same thing for 1,000 grams is a kilogram. I gave you that relationship up here. Well, this time I put 1,000 grams on top and 1 kilogram on the bottom, or 1 kilogram on top and 1,000 grams on the bottom. Okay? Now remember, kilo means 1,000, so if I have kg, that actually means kilogram, and since the prefix kilo means 1,000, it actually means 1,000 grams. So a kilogram is 1,000 grams. So know those prefixes. Then here's another, I gave you the relationship for minutes and hours. And here's 2 conversion factors I can use. And then 60 seconds. So what would be one more conversion factor for 60 seconds is 1 minute? Well, I could put 1 minute on top and 60 seconds on bottom. It just depends on what unit I need to end up with. All right, so we're going to practice doing some conversions using bridge notation, and it is important that you do bridge notation. This right here is what it's called, bridge notation. I really am going to require you do it the way I do it, and there's reasons for it. It will help you do better in the long run. So we're going to convert centimeters to kilometers. All right, now if you look at my mnemonic device, this is centi right here, and there's a kilometer right there. I've got to get to those from one to the other, but I'm going to have to go through the unit. So you often have to go through the unit to go from one side to the other. So I'm going to turn my centimeters into the base unit, and then the base unit into the kilometers. So I've got to know the relationship between centimeters and the base unit. And this is where I normally write, when I'm doing the math, I do it like this. Gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk. I like to do the little D's, C's, and M's on the other side because these are getting smaller. Space, this is the symbol for micro. It looks like a fancy U. Space, nano. All right, I'm going from centimeters to kilometers. So this is the centi, and this is the kilometer. And I usually write unit right here for me to remember that this is where the base unit is without any prefix. Okay? So I'm going to go from centimeters to meters because we're right now dealing with meters. So we have 132,540 centimeters. This is bridge notation. I'm going to write the unit conversion, the conversion factor. If I go from centimeters to meters, what's the relationship? Okay, you need to remember that there are 100 centimeters that's a 100, 1 meter. Because centi means 100th. So centi means 100th. So it takes 100 of them. Think about that for just a moment. If I have 100 times 100th, if centi, the C means 100th of a meter, and I multiply that together, notice how the 100s cancel and I end up with just the M for meter. It's just another way of picturing it. So centi means 100th, so I need 100 of them. All right, now the centimeters is on the top, and it's the unit that I want to cancel out. So I put 100 centimeters on the bottom and 1 meter on the top. And now let's cancel them, centimeter to centimeter. So now I have meters, but the answer is not supposed to be in meters. I'm trying to get to kilometers. So now I've got a meter. I went to here. I'm at meters, which is the base unit. The base units are meters, grams, and seconds. What else? Liters. Those are all the base units. So I went to the base unit. Now I got to get to the kilometers. All right, so I have meters at the top, and so I'm going to put meters. That's what I want to cancel out. So 1 meter needs to be on the bottom. And then how many meters are in a kilometer? Kilo means 1,000. So a kilometer is 1,000 meters. A kilometer is 1,000 meters. So I did something wrong. I said 1 meter and 1 meter. Well, that's not going to work. And I didn't do this on purpose. I just happened to notice, oh, that's not right. So I'm going to change it because I need a kilometer. I need it to end in kilometers. 1 kilometer at the top. So what I really need is 1,000 meters on the bottom because 1,000 meters is equal to 1 kilometer. This is my conversion vector. All right, now I can cancel 1 meter and meter. And so you notice I'll have the numbers on the bottom. So now what I'm going to do is go ahead and put all this in my calculator. Pull up my calculator for you. Move it over. And let's do this work. Okay, we have 132,540. And now, with bridge notation, if it has this line, it's on the bottom of the line, you're going to divide by that number. So divided by 100. All right, that gets me to this spot. Now the next spot, we have this line again, so we divide one more time. Divide by 1,000, enter, there's my answer, 1.3254. Okay, 1.3254. And what unit did I not cancel? I did not cancel kilometers. And that's what I asked you to end up with. So that's the answer. Now, I can use my gigaspace space, megaspace space, King Henry drank Ucky dark chocolate milk to check this. So how many places did I move my decimal place? I'm going to use a different color. We started off at centimeters. We went to kilometers, and I moved my decimal 1, 2, 3, 4, 5 places to the left. I ended up moving 5 places to the left. So let's look at this number, 132,540. The decimal would be over here. Let's move it 5 places to the left. 1, 2, 3, 4, 5 places. Notice it's between the 1 and the 3. That's what I have. So I use this as a mnemonic device, but also as a check. Now this is bridge notation that you have to know how to do, because not everything is going to be on this metric line that I used for you. Now let's go ahead and try the next one. We're going to turn milligrams to kilograms, and this is an easy one. It's one we're going to use a lot. So let me erase some of this. We're going to turn milligrams to kilograms. King Henry drank dark chocolate milk. All right, milligrams are right here, and we're going to go to kilograms right here. So we're going to still have to go through the base unit. So we're going to go from milligrams to the base unit. So 350 milligrams. And we got to, okay, what's the relationship between milligrams and the base unit? Well, the milli means 1,000. So there are 1,000 milligrams is 1 gram. I have milligrams on the top, so I need milligrams on the bottom. So 1,000 milligrams on the bottom, 1 gram on the top. We're going to cancel it out. And so now I have grams, but I don't want grams, I want kilograms. So I've got to go from the base unit to kilograms. So now I'm going to put, what's the relationship between kilograms and grams? There are 1,000 grams in 1 kilogram. That's the relationship. The grams need to go on the bottom because the grams are on the top here. So 1,000 grams on the bottom, 1 kilogram on the top, and cancel the units again, just like you do numbers. So now 350 divided by, because if it's on the bottom, you divide by 1,000 and divide again by another 1,000, and that's going to give me my answer. Pull up my calculator. Let's do that. So 350 divided by 1,000, divide by 1,000 one more time. Whoops, go back, I don't need that. There we go. Enter. 3.5 times 10 to the minus 4. So 3.5 times 10 to the minus 4. That's what the calculator said. Let's look at that again. E means exponent. The exponent is a minus 4 on the base 10. E means exponent. There's the 10. It's the thing minus 4. Do not write E minus 4. Okay? Now, that also means 3.5 times 10 to the minus 4. If we put that in standard form, then the minus 4, I always do this, draw an arrow. I mean, you know, it says minus 4, just put a little arrow on it. So that shows you that you're going to shift this decimal to the left to get it back to standard form, not scientific notation. So I have to move it 4 places to the left. 1, 2, 3, 4. And put a 0 and a 0 and a 0. So that's 0.00035 kilograms. That's another way of writing this answer. I wouldn't require you to do standard notation, but you can. And notice if it's a negative sign, put an arrow and move the decimal that way. Now, let's use my Gigaspace Space mnemonic device again. There it is, 350. The decimal's right there. I started off at I started off at milligrams. I went to kilograms. How many places did I move? 1, 2, 3, 4, 5, 6 places. So 1, 2, 3, 4, 5, 6 places. Put zeros. So it's 0.000350. 0.00035. I just left off the trailing 0 at that point. So it proves I did it right. Okay, I'm going to put this one and this one up for you, and you can look at it for a few minutes, and then we're going to do some, well, I'll tell you what, I'll go ahead and do this next one. 670.7 nanometers to meters. 670.7 nanometers to meters. I'm going to go ahead and write my mnemonic device again down here. Gigaspace Space, Megaspace Space, King Henry drank dark chocolate milk. Space Space Micro, Space Space Nano. I'm going from way down here, nanometers. Remember, this is the unit, the base unit, to meters. Well, meters is a base unit, so I have to go from nanometers to meters. This is a one-step process, and I'm not going through the unit to go to the other side. So 670.7 nanometers. A nano 9 is how it helps me to remember it, but nano is really tiny, so it's 10 to the minus 9 meters. Or it's a billionth of a meter, so it takes a billion of them. So we want meters, so that needs to go on the top. I know, because I just said right there. But what's the relationship between a meter and a nanometer? Well, it takes 10 to the positive 9 nanometers to make 1 meter. Or 10 to the minus 9 meters is 1 nanometer. Or what I really like, because I like just look at whole numbers, it takes 1 billion nanometers to equal 1 meter, because a nanometer is so small. But you can use 10 to the 9. So there's 10 to the 9 nanometers is 1 meter. You have to remember these. You have to make yourself some cards or something and get this straight. So this is a single step process. Nanometer and nanometer cancels. We just have to take this number and divide it by 10 to the minus 9. It's probably going to be a very, very small number. So let's do it on the calculator. 670.7. And we're going to divide, because it's on the bottom, by 10 to the minus 9. So we can do this. 10 divided by 10 up caret 9, not minus 9. 10 up caret 9. So 6.707 times e to the negative 7, which means the exponent is a negative 7 now. All right. So 6.707 times 10 to the minus 7 meters. There's the answer. And you could also do it with my mnemonic device. How many places did I move it? 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So 670.7. Notice there's the decimal. Move it 9 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And put zeros. All right. Well, that doesn't look like that. Well, we could turn that really small number into scientific notation by figuring out how to get the decimal right there. So let's move it 1, 2, 3, 4, 5, 6, 7 places. To get it right here, it has to be moved 7 places. So 6.707 times 10 to the negative 7. I know it's negative because it's you put a negative exponent if the number is super small. This number is way less than 1. If the number is less than 1, your exponent is going to be negative. Okay? This is scientific notation. This is standard notation. It's one of those times when the number is super small, this is the better way to do it in meters. Now, I know this is a little bit more difficult, but you just have to practice. Okay, I'm going to pause the video for a moment and work this next one out for you. Let's see how you do. All right, I wrote out the problem. I erased a little bit first. I wrote the mnemonic device. We're going this time from a mega to a milli. And so we had to go through the base unit. That's this first one. Mega million. So there are 1,000,000 grams in a megagram. And then from the megagram to milligram. And there are 1,000 milligrams in 1 gram. These are the relationships or the conversion factors. I put megagram on the bottom and canceled. I put gram on the bottom. They should be really like that, as quickly as you can possibly get. So they're on the bottom, so they cancel. And now all we need to do is do the math on our calculator. All right, so let's go ahead and do that one. 0.0043 megagrams. Okay, we're going to multiply it now by 1,000,000. So 1,000,000, or 10 to the 6th. And we're going to multiply it again, because if it's on the top, you multiply it. If it's on the bottom, you divide by 1,000. 1, 2, 3. Enter. So 4, 3 with a bunch of zeros behind that. 1, 2, 3, 4, 5 zeros. 43 with 5 zeros. 43, 1, 2, 3, 4, 5. Now, I can check that again with my mnemonic device. Move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So if I write the number and move it 9 places, 0.0043, move it 9 places to the right. I got to follow the arrow there. I move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Put zeros after it. And I end up with 43 with 1, 2, 3, 4, 5 zeros after it. Because now these leading zeros are gone. So yeah, it worked. And the answer is milligram. Okay, so now on your seat practice, you have all these to do. I want you to pause the video and try all of these. And then when you have tried them all, start the video back up and check your answers for all of these. Get these right. Notice I wrote the mnemonic device at the top. I used it to count to double check some of these problems. This one, and you know, can use it to double check these three. This one I can't because we're talking about days and hours and minutes, which are not on this metric mnemonic unit or metric line that we're using. So I hope you got this right. Now we're going to quickly go over to the Prezi and see if there's anything I did there. Notice that this is the Prezi for chapter 3. There's Quizlet terms. All you have to do is click on that. If you're at home, just click on it. Comes up with a study guide, study set for this, and has all those units you need to memorize on it. So spend some time on that Quizlet, practicing, getting that down so you don't even have to think about it. And this is just what we did before, the freezing point, the boiling point. And this is, if we agreed that the student was a toddle long, then we'd measure how many toddles each person was. So these are the ones we talked about that you have to memorize: length, mass, time, and temperature. And those are the units you have to memorize. And this is a major metric mistake. Let's look at this for a moment. This is just talking about how in 1999, metric math mistake cost all kinds of money. A disaster, because they measured things using the metric system in one spot and using the English system in another spot. And because they weren't using the same units, if you read on through here, it ended up just destroying things and costing a lot of money. I don't have time to find exactly the spot to look at there, but you can go back and look at that. It's an interesting article. And then the unit conversion is just the process. The process is the unit conversion. The conversion factor is the tool that we use. So tools that you use are the conversion factors to do the process. And so we just did all these already. So back to our notes. All right, so that's where we are. I hope you did well. I will see you in class.